Good afternoon, and thank you for joining the Association for Project Management Planning, Monitoring and Control Specific Interest Group. My name is Mila, and I'm the chair of the APM Planning, Monitoring and Control Specific Interest Group. I'm really pleased to have with us today Dr. Pablo Ballesteros-Pérez, who is a civil engineer and who is currently working at Loughborough University as senior lecturer in the School of Architecture, Building and Civil Engineering. We also have with us Dr. Stefán Thor, who is a lecturer in energy systems and the built environment at the University of Reading. I will get them to introduce themselves in more detail shortly, but I would like to thank you all for joining us for this webinar, and please do let us know what other webinars we should consider from the Planning, Monitoring and Control Group for you. And I'll just pass along now to Dr. Pablo Ballesteros-Pérez to introduce himself.
Well, thank you. Good afternoon. Well, thank you, Mila, also for introducing us. I'm here with Dr. Stefán Thor. We have been the researchers of the research project, which is about to finish now. It's been going on for a year, and we are finishing it this month. We will show you a few things and outputs that we've been producing, and we hope actually that they are very useful to you. Well, to start with, this is a project that was funded by NERC a year ago, which was about basically the influence of weather on infrastructure. We started with building construction mostly around 2 years ago while I was working for the University of Reading, and I recently moved to Loughborough University. So right now this project, which you are going to see, has produced a website application that you will be able to use and provide us feedback if you want to. And we hope that it's very useful so that you can plan much better how your construction projects will evolve and be influenced because of the weather and many things, as you will see now. Okay, let's begin. As we were saying, this was funded by the Natural Environment Research Council. It's a project that lasted 12 months, and we've been using actually lots of weather data supplied by the UK Met Office, which was actually very demanding to get. And it's been developed under the Environmental Risk and Infrastructure Innovation Program, RIP, and this is the grant number in case you wanted to establish contact with us or with someone from the organization that actually paid for it. And the principal investigator is now Stefán Thor. I am the co-investigator, and there's also another computer programmer, Peter Cook, which has been involved in coding all the application that you will see. Okay, we are going to show you is we've been publishing and working on the area of weather forecasting and the influence of weather in construction productivity for a few years now, and there's lots of theory, lots of things and models, but we actually wanted to bring everything down to earth and come up with a tool that everyone could use to plan the projects, the construction projects, in a weather-aware fashion, which means that considering the weather before actually that the weather impacts our construction schedule. So we are going to focus on the time dimension, not that much in the cost dimension, but it shouldn't be very difficult to actually understand. This is the first step, and I think it's enough for now. The idea is that every construction project is going to be influenced by the weather as long as it is performed or carried out partially outdoors, which means that if you have an activity like concrete or steelworks or formworks and you are exposed to the weather, it is likely that at some point or some days during the execution of each activity, you will have problems because high winds or because of too much rain. So those productivity declines need to be accounted for somehow. And this is exactly what the tool that we've developed does for you. And we will be able to use it also backwards, which means that from a project that has been completed, we will be able to measure how much the weather has influenced that schedule, which is very useful for many things, like, for example, mediation with the project owner when it comes to discussing time extensions or cost compensations because of extremely adverse weather. We will show you very shortly what we consider weather-sensitive activities, how did we process the weather information, how did we transform it into a series of simple coefficients so that we could consider the productivity declines, and a few maps with the outputs that are included in the website application, and a few applications that you can actually play with the tool that we've developed. There are some more, but we've actually concentrated into the 3 most relevant. So now begin with the real webinar. So now pay attention, please. This is the most relevant bit, probably. I guess that you can see the arrow here in my screen. At the top, you can see a series of 6 standard construction activities: earthworks, formworks, scaffolding, concrete, steelworks, outdoor paintings, and asphalt pavements. These are just a set of 6 standard typical construction activities. And here on the left, you can see a series of weather variables and thresholds beyond which, if we are experiencing that day, for example, a temperature below 0 degrees, it means that some of these activities could not be performed. For example, concrete is particularly a highly sensitive activity to very low temperatures. If we have temperature dropping below 0 degrees, then we couldn't actually pour concrete. The same happens with very high temperatures, like above 40 degrees, with precipitation above 10 millimeters, or wind gusts above 30 knots. For every activity, we have chosen a series of combinations of weather thresholds, which means that despite these might not be perfectly accurate always, they provide us with an average threshold or rules of decision with which we can actually consider that an activity will have some problems or productivity problems when being performed. With these thresholds, we selected them actually from a series of papers published on this topic. There are not many papers actually so far published on the intersection of building construction and infrastructure construction with weather, but there are a few regulations from some countries, particularly the US and Spain. From those papers too, we try to come up with some approximate thresholds which can be useful for actually telling apart whether an activity will be able to be executed or not. So let's consider that we have assumed that these are the thresholds. For example, for earthworks, any precipitation above 10 millimeters in a single day, it's just too much. We produce too much mud, it will be difficult to work with machinery, equipment, etc. And the same for the rest of activities. You can go back to this table later if you want to understand the details of it. With having chosen that, the next step was to retrieve weather information. We went to the UK Met Office and downloaded the last 30 years of data. Every single day was registered for these variables, the ones that we had shown you before: daily max temperature, minimum temperature, mean temperature, total precipitation, rainfall, maximum gust, days with snow, days with hail, days with thunder. With those results here, with this data, basically we counted how many days per month, per year were workable. That means that there were no good weather conditions, no extreme weather conditions, and we could actually carry out the construction activities. When we didn't have a weather station which was close to our construction project or construction location, basically we resorted to a few weather stations, and we took like kind of a weather weighted average to get a rough idea about how good the weather conditions were in this point located in the middle of a few stations. So in the end, this is a simplification, not actually what we really did, but it's the first step so that you can understand and follow us. In the end, for these standard construction activities, earthwork, formworks, scaffolding, concrete, and for every month, we calculated a proportion of workable days, which means that, for example, earthworks in January could be performed without any kind of weather-related problems 86% of the time, 86% of the days in January. As you can see, of course, and as it is to be expected, throughout the year, particularly in June, July, August, we have the highest productivity rates for earthworks. There are some activities which have the peak with highest productivity in a different month of the year. But to put it simply, basically, we did this for every single month and for every type of activity. With these 6 activities, of course, we can represent probably 90% of the most common construction activities, which is enough for having a rough idea about how the weather will influence any construction schedule which is performed partially outdoors. The next step was to actually, since it was very time consuming to keep calculating and retrieving the data for every single project location, what we did is to retrieve directly all the weather information from all weather stations which contain from 20 to 30 years of weather information here in the UK. Here you can see the numbers of all the weather stations. Eventually we found 102 stations, but despite I told you this a minute ago, actually we didn't process this information on a monthly basis, but on a daily basis, which means that we could produce actually day by day weather influence forecast for every activity.
Just to point, that was using hourly data from the MIDAS database.
Yes, right. Okay, so next step was, now we knew what we wanted to do with the weather thresholds and weather variables that were representative for a set of construction activities. We found the weather stations that could provide us with the right amount of information. The next step was to process that huge amount of information into something that we could handle easily. So in this slide, you can see how these black lines oscillate a lot. They represent the daily productivity rates from the first day of the year, 1st of January, to the last day of the year, 31st of December. And this is representing the average productivity over the last 20 to 30 years for every single day. Of course, every year is different. Climatic conditions have a lot of variability and volatility, which means that we cannot work with that many points for every single calculation. Otherwise, it would be too computer demanding. So what we did is to simplify this much more and to fit sine waves, which are represented in red here, to consider that they are representative of the average annual variation for each activity. So here, for example, in this figure, the top with a green background, this is steelworks activity in this weather station in Tiree. Instead of using these black lines, we just simplify this, and from now on we will be using the red lines. As you can see, the coefficients of determination, the goodness of fit of these lines were relatively decent for such a big simplification. The same happened with the rest of activities. Here you can see the concrete activities in this weather station, Guernsey Airport, or formworks scaffolding. The difference between these curves is that I think it's very relatively evident. For example, steelworks suffer from a big variability throughout the year, whereas formworks is not that much influenced by the weather, because as you can see, most of the year the productivity rates remain very high, close to 1. So the thing is that from thousands of points and hundreds of stations, we had simplified this to very simple mathematical expressions, sine waves, as we are saying here. Sine waves are mathematical expressions that, if you don't remember from when you were attending school, depend on a series of parameters, and we just simplified to three of them. K, which represents the average throughout the year. It's like a line, horizontal line located in the middle. The amplitude, which represents the maximum annual variation, the distance between the lowest and highest productivity throughout the year. And Phi, which represents the moment of the year when we have the peak in our productivity, the best day of the year to execute a particular activity. So three parameters. With these three parameters, what we did after processing all 102 weather stations is to create these maps. Let me explain them to you so that you can actually see the usefulness of this. These maps are representing formwork or scaffolding activities in the whole UK geography. This blue zone here means that this is the area in the UK where you can have a higher productivity rate, where you will find a highest proportion of days when you can work and not be stopped because of the weather in any way. As we go close to the coast or go north, of the weather conditions get worse. Here we are around 0.82, 83, whereas here in Scotland we are close to 0.7, 0.6. And so this provides an accurate picture of how easy, how productive you can be when considering to build a construction project anywhere in the UK. Here, this represents the average conditions for every single day of the year, but here you can see the same for the amplitude and the same for the phase shift, which means the best day of the year to actually execute that activity in per unit basis, not in, but you can just multiply by 365 and get the best day of the year. So just in a nutshell, because otherwise we will lose the focus here, this is the most relevant map, which represents the average weather conditions, the average productivity rates that you can achieve for formworks and scaffolding.
I would say one other thing, in reading these maps, you should, although the contours and the colouring goes out beyond the land borders of the UK, you shouldn't be reading the maps outside of the land borders. This is specifically for construction on land.
Exactly. Yes, right. The next thing that we did is to simplify this even further, which means that instead of using three parameters, we resorted to a single one. We express the amplitude and the phase shift as a function of K, which means that from now on, and we then prove in a paper that we recently published that with only handling the single parameter, we could get rough, decent approximations of how the weather impacts the construction schedule. So what we will be showing you now is the result of applying these maps for planning any construction schedule. Okay, and now this was the theory behind the project that we've been working on this year. But what we did was actually to produce a tool. That was the final aim of this research project. We are going to show you what you can do with this tool now. So you can probably empty your memory again and forget everything we've told you. You will be able to read in some help in our tool later. But in case you are interested in what you really can do and how you can benefit from what we've developed, this is the most relevant part. Okay, imagine, for example, now let's start with the construction of a reinforced concrete building. This is a very simplified, of course, representation of a Gantt chart representing to the left the activities that you need to perform to complete this building. Here to the right, you can see the time it takes to complete those activities, and with different colors, we are representing the combination of weather variables that is representative of each activity. So, for example, site marking might be well represented by earthworks activities, excavations, of course, by earthworks, laying concrete by concrete, steelworks for reinforcing steel, and so on. In light gray, you can see activities that are not influenced by the weather, either because they are covered, for example, they are performed in floors which have already been built, or because they are just activities that have nothing to do with any activity that takes place outdoors. So from this construction schedule, the first thing that we normally would like to know is how longer will it take to actually complete this project once the weather is influencing our schedule. So we are assuming that we are starting in January, the 1st of January, is saying 17, but it could be any year. 1st of January, we were supposed to start this project. How longer will it take? As you can see, by the middle of July, we should have finished this building construction. So with the tool, this is one of the graphs that you will be able to obtain. It will calculate for you, if you start on the 1st of January, the 2nd of January, the 3rd of January, every day of the year, how long will it take on average to complete that project? Here you can see the project duration, in the y-axis, and in the x-axis when you are starting. So it's plain to see actually that if you started your construction project in this month, approximately, more or less, from the 1st of May up to the 15th of July, you will get the shorter project durations. Shorter project durations are beneficial for many reasons. For example, the overhead costs will be lower, the indirect costs will be lower too. If you have no choice but to start towards the end of the year, then you need to assume that your project is going to last much more. If it was 115 days here it will be around 142 working days. So there's a difference, and you can play with this time gap to your own profit, which gives name to the name that we gave to the project, weather-wise, which is basically making the most of the weather by not ignoring it, but on the contrary, to embracing it and using the potential influence to your own sake, for your own sake and benefit. So here in red lines, you can also see the confidence intervals, in case you were interested in those things. But the main thing is that the project duration is different depending on when you start. Sometimes, of course, you cannot change the start date. Sometimes you cannot change the location. But as long as you can play with some variables, you should be able to actually take advantage of this type of graph somehow. The next application is, okay, what we have shown you is the construction of a single building. What happens when you have a construction project that is located in multiple places at the same time? For example, a highway, a smart motorway. Normally you will have different construction sites open at the same time, which means that you might want to optimize or to prioritize some places over the others, bring the resources to the places where they can actually produce most work. So this was, so far we have shown you an application in the UK. We also developed these similar maps in Spain and in Chile too, places where we have been working before. And for example, in Spain, imagine that you need to build a highway from this point to that point. Okay, and you have 5 different places. You might want to know at every point of the year, at every moment during the project progress, where to actually move your resources so that you can produce more. With those things, for example, we have shown you an application for every single city of Spain. We can calculate for every single location, if you started the project in different moments of the year, how long it will take you to complete every different project that you can plan. With this matrix, you can actually optimize lots of different things. You can calculate duration extensions, cost extensions, and things beforehand before actually starting the project. The third application, it's to use the web application that we've developed backwards, which means that in a very common situation, sometimes many contractors need to negotiate with a project client or a project owner because they've been experiencing what they think are very adverse weather conditions. The problem is that weather is something complex. It has many variables, many manifestations, many waves. It is a gray scale actually. So how can you be sure when you're negotiating with someone, unless it's a catastrophic event, that your weather conditions haven't been very favorable, and actually you are entitled to claim for some kind of compensation somehow? Okay, so what we did basically was to apply what you've seen but backwards. What does that mean? Okay, imagine that you've been building that reinforced concrete building that we were talking about before, and during your construction period, since you started in 2017, as you were saying before, we've been registering the productivity days for every single day of the month until the project finished. And now what we are going to do is to compare if these actual coefficients are very adverse or very favorable compared to the average weather conditions that we have been registering over the last 30 years. And you don't need to register absolutely anything. That's the good thing about the tool. It will register everything for you. The tool will just need that you include the construction schedule, the start and finish dates of every single activity, and for you it will calculate all the possible project durations that you could have seen from the last 30 years in lots of Monte Carlo simulations. In this example, you just need to know where your actual project duration is. Here you can see, because you've included that schedule, that your project is lasting around 139 days. How does that compare to the previous 30 years? Well, actually, the average was here in 133 days, which means that, yes, your weather conditions have been harsher than usual, but because it's about the 50%, but not that bad, so that you are the top 10% of the most adverse weather conditions. Maybe, I don't know, this is something up to every contractor and every contract. You could have negotiated with your client that if you are in the top 10% of the weather conditions, you are entitled to a cost compensation. Whereas if you are above the average weather conditions, like it is the case here, you are entitled only to a time compensation. So, for example, a very objective way of negotiating with your project owner would be that you're asking for 6 days more than what you had assumed in your construction schedule, so that no penalty is applied for late completion. You don't need to do anything else. It's as easy as that. Okay, of course, we need to assume that this is an application in beta version, so you cannot do a few things, very advanced things, but the most basic things are available to you. Now, the tool is going to be hosted somewhere else, but here for now you can find a provisional link where you can access and play the tool. The link is protected. You need to include this username and password so that you can access what we are going to show you now. Once we have the final location of this tool, it will be included in the next webinar link so that you can access it, and also we also include a message in this website so that you can be redirected to the right place. Now we are going to show you, if you clicked on that link, what you can do with the tool. Once you access the link, before it is moved, you will be able to see a screen, a white screen, with some information about where this application comes from, with our names here, and a series of schedule examples. You won't be able to remove anything from here, because for now it is protected, but you can edit things and you can add new schedules, so you can actually make the most of this tool right now. Let me show you how the tool works. Here you can see the list. We're going to play now with the demonstration schedule. You could create a new one by clicking on here, starting from scratch, including all the project name, start date, etc. But we are going to show you something with a few functionalities with the demonstration schedule. So here you can go access directly to the Gantt chart, because it's normally very common that you want to see directly the Gantt chart, but also you can input more data here or delete it, but for now you won't be able to do that. Let's go to edit. Once you click on this window, you can see a demonstration schedule here. This is the name of the project, this is the start date, and this is a project status where you can choose 3 options. Not started, which means that all the dates are considered to be happening in the future. Complete, which means that everything is in the past, you've already completed the project. And in progress, which means that you are in between the start date and the finish date. For now, we will remain in progress. Depending on whether you choose not started, complete, or in progress, you will be able to see different options here. For in progress, you can see everything. You can go forwards, which means planning for the future, or analyzing the past. In complete, you can only see the past. In not started, you can only see the future. The next thing that you can do is to choose the working days. Normally, we don't work on Saturday and Sunday, but you can include them if you want. And the next thing is that actually, which is crucial, is to explicit where this project is going to be built. Here you can find 2 random project locations. You could create a new one by adding a new location here. You can put the name, any name you want, so that you can remember, including coordinates here, or just clicking in the map. Okay, we are going to cancel because we don't want to record this. Once you have specified as many locations as you need, for example, for a highway, you might want to specify 5 construction sites or even more, we will go back to a schedule. Just remember that these are York and Southampton. The next thing is normally you want to include or to actually modify the construction activities. Here we can see a series of activities that we included beforehand so that you can see them. For each one, you can see the duration in working days, the location that we consider for each different activity. Sometimes different activities will have different locations. Most of the time, most activities will share a single location. And the type of activity that we assume to be representative from the weather point of view. For every single activity, you can edit them or delete them. Lean concrete, for example, is going to last 1 day. If in this case, it's pretty obvious that lean concrete is related and represented by the combination of concrete activities. But if you felt the earthworks or formworks are actually more reliable, that the combination of those weather thresholds are better for this activity, then you can change. You can change it. Location, it was York, but it could have been Southampton. And when do we want to actually place this activity? For the calculations, that doesn't change much the outputs, but actually, if you want to reorder the activities and organize them in a way that are easy to understand, sometimes you want to play with the location of this activity. With dependencies, you can include 2 types of dependencies. Normally, most of them will be finish start, sometimes with a time lag. This means that, for example, if you include a 5 here, it will mean that once the excavations are complete, 5 days later, you will start with the ongoing activity in concrete. But you can also include negative duration, which means that before you finish the previous activity, you can start the previous one. And also, you can include, if you want, start to start predecessor relationships, or as we were saying, finish to start. We are going to cancel this for now. Back to activity. So this is the list of activities. Now that we have included all the information, it is very straightforward. You could see, for example, the Gantt chart. Here we can see all the activities. As you can see here, we are in the middle of the construction progress. So normally these activities will be extended because of the weather. Despite you might have said that this activity was going to last 40 days, actually it will last on average 42 days once the weather has influenced this activity somehow. If we want to see the original schedule before exactly the data that we included in the schedule, you can click here, and this is the original. If you want to see the one with the weather, you can see here, you can see how it is stretched. It takes longer. You can play also with the displays with the time units if you want to visualize a whole construction schedule or only part of it. The Gantt chart is very easy to understand. The next one is the stochastic project duration. It might take a few seconds, sometimes 1 or 2 minutes to calculate this. But here you can see, if you assume that you're going to start, in this case, on the 1st of January, you could have changed that before in the project start date. What are the chances of actually completing this project for these different durations? So for example, now we are approximately in 50%, which is around here. For this project, it will last around 125 days. But if we wanted to know, okay, what are the chances that we complete in 4 out of 5 occasions that we complete the project, then that would correspond to 535 days. In 80% of the time, we will complete the project in a shorter time. But it might take much longer, depending on the weather conditions, of course. Sometimes even get very close to 600 days. What this figure provides us with is a probabilistic picture of the different project durations that we can be actually seeing in our project once the weather is impacting our schedule. Okay. The next thing is to analyze by project date. If we could play with different project start dates, how long it will take to actually complete the project. Here you can see that totally unlike in the previous example in the applications, this type of project will take longer to complete if we started in between May and July, August, because this is the middle of the year, exactly from day 1 to day 365. So if I was the project manager in this particular construction project, I would try to actually launch this project during the first 3 or 4 months of the year, because here is when we will have the shortest project durations. There's not a big difference, probably around 10 days of difference, which will be around 2 weeks. But well, it's something that you can actually use to your own benefit. So with this graph, basically you have an overview of when it is better to start the project. We go back to a schedule. We've been showing you what happens from now moving forward, but if you are interested in what has been happening before, how adverse were the weather conditions, you can also go back to a Gantt chart, which provides you with a very similar view to the Gantt chart that we have shown you before, and also the stochastic project duration, which is useful for claims. Okay, now what the tool is assuming is that the activity durations located in the past before the current status date, everything has been completed, and it's calculating what would have been the activity durations before the influence of the weather, and then expose them to meet those original activity durations to lots of synthetic artificial weather years that the tool is creating for you. So you can see, for example, here we can click that our weather conditions are approximately in 2/3. This is our current project duration with this probability. It could have been worse weather conditions, but it's certainly above average again. With this, we can know objectively how bad the weather conditions were during the days prior to our current date. So it's very useful because it provides you with a basis for discussion, something for actual negotiating in a tangible way.
Yeah, we see it as the potential of, before the project starts, you can set some threshold at which, as Pablo was showing earlier, where you would see potential for compensation. So whether that was if it was more likely that 2/3 of the probability of a shorter duration, then maybe you would want to negotiate some leeway in terms of what's expected from you from your client.
Okay, that's right. Well, and basically this is all. You are welcome to. Oh yes, please. Before I forget, there's for those of you who can't remember absolutely everything that I've said because I've been speaking a lot, you can click on the button here and you will access a user guide with the complete instructions to actually make the most of this tool. It's not complete, it's still on the way, but it will be completed very, very soon, probably in 2 or 3 days. So, well, please feel welcome to send us feedback and to provide us with any useful comments, constructively, of course, and we will consider them for future projects. And if we can help you somehow making the most of this tool, please, of course.
Yeah, I think that's quite important for us as well, as to know how it would be used in industry and where you would see the relevance and potential areas for future sort of development.
We are perfectly aware that this is not a very polished tool, that there's much more effort that can be put into this to create a better interface, something that is smoother. But of course, this is a first trial, the first attempt, very first attempt actually to include the weather. It's not easy to include so many things in a single tool in a way that is easily understood. So please, anything you think that you can complement this nicely, please contact us. Here you can see our details in case you want to send us an email or give us a ring. Please do it. CIRIA has been overseeing our progress over the last months, and NERC, they are the funders, and these are the people in charge. Anyone, please feel free to contact them. Thank you, and this is all. We welcome your questions, I think. Yeah. Thank you. Yes, actually, we published a paper in a journal, Construction Management and Economics, very recently. In that paper, anyone can find all the theory behind the tool, all the sets with weather maps from the whole UK. So you can download them as supplemental online material. My colleague Stefan is accessing the paper now. It's open access, which means that it is free for anyone. So there you will be able to see the theory, how we computed the sine wave curves, and download all the grid data from all the process weather data. So it's everything is there. The tool is for you to actually take advantage of it. But it's one of the most recent papers, so it's very easy to find. We will include a link with the webinar link if you wanted to. Someone is so bored that wants to actually spend some hours reading this.
That's great, thank you.
All the weather maps are included supplemental online material because they are very heavy. So you need to download them separately, but you can find it in the supplemental tab.
There are some forms of contract that already define sort of adverse or exceptional weather. Do you think this has been taken into account of in the analysis?
The thing with weather conditions is that it's a gray scale. It's not black or white. I mean, unless you have a flood and you really have problems in your construction site because you've been having rain for 10 days in a row, and it's so evident that there's been damage because of the weather or unusual weather. Normally, most of the time, you are playing in between the grayscale, which means that in some weather variables, you might have more rain than usual, but maybe you might have less wind than usual. And overall, you need to come up with some kind of average. So the good thing about this tool is that you can agree of a series of thresholds for each weather variable, and then everything will be recalculated according to those. So we can say 10 millimeters for rain or 0 degrees for temperature, but we can change those limits. Not now in the tool, in the current version, but we will be able to do that in the future. And once that has been agreed between the contractor and the project owner, everything that happens from that point on can be measured in probabilistic terms. So it is very useful.
Yeah, and I think just to add to what Pablo is saying is that it's also around sort of your definition of adverse, because you could have an adverse condition or event which may have some but minimal impact on a project duration, where you could have a series of weather events which you wouldn't necessarily say individually were adverse, yet collectively they build up to have more of an impact on the construction duration.
Exactly.
And so that's kind of one of the key points of the tool and the approach, is that it sort of will take all of that into account, so that you're not having to argue a definition of adverse weather, but more argue a point on the sort of the climatological scale, those sort of S curves, cumulative distribution curves that we showed. You're just saying, well, actually, where we want to define this is as a threshold, as opposed to a particular description of a weather event or weather conditions.
And also you need to take into account that every construction schedule normally has tens or hundreds of activities. Every single activity is influenced by the weather in a different way, by different combinations of weather variables. There's no way that a human can calculate for every single activity and every moment of the year how it is probabilistically likely that something will happen. The tool does everything for you. So you just need to define the weather thresholds, and then every activity will be automatically influenced forward or backward, depending on whether you have completed or you are going to start the project. So it is way easier. You just concentrate on the things that matter.
So a follow-up question to that came in, just to clarify, is if a contractor sort of came back with a list of delays on particular dates due to weather, is that something that could be inputted in with the location and find out if there was a valid claim?
Yes, I mean, you can, what you basically do when you are looking backwards, that is when you have completed or partially completed a project, is that you include the actual activity durations. Then the tool calculates for you how long those activities would have lasted if the weather had not influenced those activities. And then it recalculates according to the last 30 years. The thing is that with that, you can know for sure, for example, because normally contractors concentrate on a few key activities that have been delayed because of bad weather. But what happens when actually there were lots of months before where the weather conditions were so good that actually you could expedite, you could accelerate your project, you didn't claim anything. So the tool will take everything into account since the moment you started up to now, and it will give you the average considering everything. Of course, you can include only a subset of activities and see the influence in those activities in particular, but you can also calculate everything altogether. So yes, answering the question, yes, you can focus on a few activities or you can extend it to the whole schedule.
And there's been a question that's come in about the actual use of the data. Is it going to be stored sensitively? Is there a sort of an open access to it after someone starts using it as a project?
For now, it is open because we want to receive feedback. And this is just to prove the usefulness. The aim of this project was to develop something that could be used by anyone. But in the near future, our idea is, of course, is to create profiles so that every person has a different access and you can only see your own files. So anyway, what you can do is basically to produce a Gantt chart with your Microsoft project or Primavera, whatever you want, include then upload the information here in the tool and produce and observe the analysis, the figures, and then keep them with you. So now you can see but of course someone else will be able to access those files. Anyway, I mean, we periodically will access the tool and remove some files so that there's not much clutter, but we welcome action. So for now it is open, but it won't be shortly.
And sort of longer term, it's understanding the sort of demand and sort of how much uptake there is with this tool will certainly influence what happens going forward with it. I mean, if it does prove to be something that is seen positively in the construction industry and is sort of integrated into working practices, etc., it creates a good justification for further development and starting to consider more seriously the issues around user profiles, sensitivity of information, and so on.
Thank you very much indeed. Does it cover all locations within the UK currently?
Northern Ireland included. However, of course, the weather conditions in the Isles might be not as representative as the ones in London, because as it is being surrounded by water, there's some kind of accuracy loss. Anyway, there were some. Normally, there's one weather station in each isle, so it shouldn't be a big loss of accuracy. But yes, anywhere in the UK.
That's great. Thank you both very much indeed for your time today and for taking us through in such detail the input into and then the uses that you currently have with this tool. Thank you both very much.
Thank you.
Thank you.
Thank you.